Here is a beautiful question I come across a few days ago, and it took me 2 days to solve this problem. And I really think it's interesting problem and solution. So we are given a triangle here. We construct 3 squares on its sides. Between 2 adjacent corners of these squares, we construct another square. Similarly, this similarly here and similarly here. Now we draw 3 lines on the exterior corners of the squares, and we go to triangle, and we need to show that this exterior triangle is similar to the triangle in the middle. So the first gamble I took is that I decided to try to show that not only they are similar, but they are parallel in their segments. So this is parallel to this one, this parallel to this one, and this parallel to this one. So this is our objective at this point. And the first thing to do is try to see what property can we have about triangles, a triangle with squares on its sides. So here is a triangle, and you construct squares on one of its sides. Let's call it the blue squares, the blue square, and say the red square on this side. So we got here another triangle, and there is a relation between these two. They are dual in some sense, and I would like to show something about the median of one of these triangles, how it relates to the other triangle. Say the median in this triangle. So we take a median here. One of the things to do when you see median is to continue this median to the same length in order to get the parallelogram. So this is parallel and equal to this red one, and the blue one, and the blue one is parallel and equal to this one. And this is since these two diagonals are dividing each other into 2 exact equal segments. So now looking on this triangle, let's shadow it by green. It's have 2 segments equal in the to this triangle, to this yellow one. And if we show one more angle equal, the angle in between, we are done. So let's show that this angle is equal to this one. So since these 2 blue segments are parallel, this angle complete this one into 180 degrees. Since these 2 angles are 90 degrees, the sum of these 2 angles is also 100 degrees, and therefore these 2 angles have to be the same, and therefore these 2 yellow triangles are similar. Hence, if this is the median with length MA, this is twice MA, and this segment equal to this one, and therefore it is twice MA. So with this one property, that this segment is twice as the median of the other triangle. Not only that, if we continue the median until it hits here, let's see what happened with angles. Let's call this angle alpha. Since these two triangles are equal, this also is alpha. Since this total for 100 degrees, this is 90 degrees minus alpha, and therefore this triangle having alpha 90 minus alpha, and therefore this is perpendicular to this segment, and therefore this height. So the median of this triangle is the height of the other one. It's dual, so you can do also the opposite way, but we don't need it. So we have two properties here. One, the median is the height here, and the second is that the segment is as twice as the median. So this is a property we would like to use in order to show what we needed to show in the original problem. So now let's look on this triangle and notice that this median, if this is segment A, this is MA, is equal to this, is vertical to this segment, and also is equal as half of it. So this is twice MA. Similarly, if we draw the, say, this median, MB, it is vertical to this segment, and this segment should be twice as MB. This is twice MB. Okay? And it's vertical. So this is vertical and this is vertical. So now, remember, we would like to show that this is parallel to this one. The way to show it is to look on this triangle and to show that this and this have the same proportion as this segment and this one. And why this is so? This triangle is exactly as this triangle, since having the same segment here, because this is square, and all angles are the same because this is parallel to this and this is parallel to this. And therefore this is 2/3 of MA, and therefore this is 2/3 MA. Similarly, this is 2/3 MB. Since this is exactly as this one, twice MA, and this is twice MB, we got that this and this having the same ratio, and this, and therefore this segment is parallel to this one. Since this is parallel to this segment, is also parallel to the opposite segment of this square, so this side is parallel to this side. Similarly, this side is parallel to this side, and the third side is parallel to this side, and therefore these two triangles are similar, and we are done with the proof.